what a day, what a day. Disinfect, disinfect. Oh, hi! Did you know that your body is fighting a never ending battle that you might not be aware of? Well, yes. You're exposed to a wide range of entities that could possibly bring harm to your body or worse. And these are referred to as pathogens. To name some, we have bacteria, viruses, fungi, and the like. You know, those things that just makes you sick. Yes, that one. So in response to this, your body has created a three policy system which is known as a detect, deflect, and destroy, which is enforced by the immune system. Now, what exactly is the immune system? The immune system is a complicated network of cells and proteins that work together to fight infection. It consists of cells in your body that work 24 hours a day, 7 days a week to protect you from viruses. This system is separate from all other systems that we have talked about, since this is not the typical tissue organ system type of system. Instead, it entails a variety of tissue units, organ systems, and specialized but widely dispersed defense cells working together to accomplish all of the defense processes that your body requires in order for you to survive in this extraordinarily germy world. Now, what are these network of cells? How do they work? Well, hold on to your seats because this is only the beginning. But to give you a heads up, the immune system is actually divided into two, the innate and the adaptive immune system. And to dig us deeper into that, we have Dr. Alex.
A break. Oh, hey! Have you ever wondered how our innate immunity functions? From the word innate, we were born with it. Our innate immunity is the first line of defense against germs from entering our body. It responds identically to all germs and foreign substances, usually called the non-specific immune system. Other than that would be the primary lymphoid organs that produce lymphocytes and specialized immunity cells, which consist of the bone marrow, which is also a spongy-like tissue that forms within the bones. The thymus gland is found at the back of the breastbone and above the heart. This gland-like organ matures primarily in children and gradually changes into fatty tissue. Initially, the innate immunity, which is then subcategorized into three defense mechanisms as shown in the concept map. Namely, the physical barriers, which consist of the skin, gastrointestinal tract, respiratory tract, nasopharynx, cilia, eyelashes, and other body hair. Next would be the cellular components, which comprises of the phagocytes or phagocytic cells that circulate throughout the body looking for potential threats like bacteria and viruses to destroy. Macrophages are efficient phagocytic cells that allows to hunt pathogens with less limits. Mast cells are essentially for wound healing and defense against pathogens via inflammatory response. Neutrophils are phagocytic cells that are classified as granulocytes, which is found in their cytoplasm. Their granules are very toxic to bacteria and fungi, causing them to stop proliferating and die in contact. Eosinophils target multicellular parasites and secrete highly toxic proteins and free radicals. Basophils, also the same, but it releases histamine, which acts in mounting an allergic reaction. Natural killer cells does not directly attack. Instead, they destroy its whole cell to stop it from spreading. Dendritic cells are antigen-presenting cells that are located inside the tissues and can contact external domains through the skin, lungs, stomach, mucosal lining of the nose, and intestines. Last category is the humoral responses, which consist of multiple components including naturally occurring antibodies like pentosins, complement and contact cascades. These innate proteins provide key elements in prevention and control of disease. Following steps are opsonization, a process which foreign particles are marked for phagocytosis. It tags infected cells and identifies them circulating pathogens expressing the same antigen. Step 2 is chemotaxis. It is the attraction and movement of macrophages to a chemical signal which uses cytokines and chemokines to ensure pathogens will be destroyed. Last step is cell lysis, which is the breaking down of or destruction of the membrane of a cell.
Hi, now I will talk about the second part, the adaptive immune system. The adaptive immune system utilizes specific antigens to generate a strategic immune response, commonly known as acquired immunity. It uses memory cells to learn about the potential threat and strengthen the immune response effectively. Adaptive immune responses are held out with white blood cells known as lymphocytes. There are two types of responses, antibody responses and cell-mediated responses, handled by distinct types of lymphocytes known as B cells and T cells. Now, B cells are activated throughout antibody responses to release antibodies which are protein known as immunoglobulins. The antibodies flow in the bloodstream and infiltrate other body fluids where they attach to the foreign antigen that encourages their production. Antibody binding inactivates viruses and microbial toxins by preventing them from binding to receptors on host cells. And in cell-mediated immune responses, the second type of adaptive immune response, T cells in particular may eliminate a virus-infected host cell with viral antigens all over its surface, effectively removing the infected cell well before the virus has a chance to multiply. Now let us proceed to the organ parts. Here, the secondary lymphoid organs consist of lymph nodes, small bean-shaped tissues, and serve as filters alongside the lymphatic veins. Different immune system cells catch germs in lymph nodes and stimulate the production of specific antibodies in the blood. Next is the spleen, a very soft tissue positioned under the diaphragm in the left upper abdomen. This moves the blood toward other organs as necessary, breaks down red blood cells, and accumulates and breaks down platelets responsible for blood clotting. Following are the tonsils, found between the throat and palate, preventing germs from entering the body into the mouth or nose. It covers a rich amount of white blood cells which can kill germs. Lastly is the mucous membrane, mainly the bowel, vital in the body's defense against germs, and these cells recognize and classify unwanted substances before destroying them. They also keep information about the substances to respond faster the next time.
What can go wrong with your immune system? When your immune system doesn't work the way it should, it is called an immune system disorder. One condition caused by an overactive immune system is asthma. It is a chronic inflammatory disorder of the airways characterized by coughing, shortness of breath, and chest tightness. Asthma can be triggered by common allergens like dust, pollen, or by an irritant like tobacco smoke. Some measures that help prevent asthma symptoms include stopping smoking and refraining from smoking around others, especially children, avoiding public places where cigarette smoking occurs, limiting outdoor exposure on days with heavy smog or smoke, encouraging a diet high in fruit, vegetables, whole grain, and lean protein. Lastly, avoiding allergens that trigger asthma attacks such as pet dander, dust mites, and pollen. In autoimmune diseases, the body attacks normal, healthy tissues. A common autoimmune disease is type 1 diabetes. Type 1 diabetes, also known as juvenile diabetes or insulin-dependent diabetes, is a chronic condition in which the pancreas produces little or no insulin. Insulin is a hormone needed to allow sugar to enter the cells to produce energy. Type 1 diabetes signs and symptoms can appear relatively suddenly and may include increased thirst and frequent urination, bedwetting in children who previously didn't wet the bed during the night, extreme hunger and unintended weight loss, irritability and other mood changes, and lastly, fatigue, weakness, and blurred vision. Type 1 diabetes can't be prevented, but there are measures you can take to reduce the risk of diabetes and prevent long-term complications. 1. Cut sugar and refined carbohydrates from your diet. 2. Watch your portions. Avoiding large food portion sizes can help reduce insulin and blood sugar levels and decrease the risk of diabetes. Lastly, have a healthy diet and be more physically active. Rheumatoid arthritis is also a common autoimmune disease. Rheumatoid arthritis is a chronic autoimmune condition in which the body attacks its own cells, causing pain and inflammation. While rheumatoid arthritis can affect a number of tissues and organs including the heart, it primarily targets the joints. The specific cause of rheumatoid arthritis has not been identified, but a number of risk factors such as advancing age, genetics, and lifestyle choices may play a role. There is no known way to prevent rheumatoid arthritis, but there are certain behaviors and ways that may help delay disease onset and minimize its impact on your quality of life. Stop smoking. Limit alcohol intake. Improve oral health. Increase fish intake. Maintain a healthy weight. Stay physically active. And take early action. If you think you have RA or at risk of developing the condition, talk with your healthcare provider. Early and aggressive treatment with medications that help stop inflammation is key to preventing severe joint damage or damage to other organs. That's all for the common diseases of the immune system and its preventive measures. Ms. Solanatin will present to you the summary of the immune system.
It's a very tiring day at work. Why is the immune system important, you ask? Well, to sum it all up, our immune system refers to the network of cells and proteins that fights infections in the body. It is made up of different organs, cells, and proteins that work together. A healthy immune system protects us by first creating a barrier that stops those invaders or antigens from entering the body. And if one slips by the barrier, the immune system produces white blood cells and other chemicals and proteins that attack and destroy these foreign substances. As a recap, the humans have two types of immunity, the innate and the adaptive. Innate immunity, which everyone is born with, is a type of general protection. For example, the skin acts as a barrier to block germs from entering the body, and the immune system recognizes when certain invaders are foreign and could be dangerous. Under this type of immunity are the primary lymphoid organs, which consist of the bone marrow and the thymus gland, which is then subcategorized into three defense mechanisms as shown below, namely the physical barriers, cellular components, and humoral responses. Adaptive or active immunity is developed throughout our life. We develop adaptive immunity when we're exposed to diseases or when we're immunized against them with vaccines. This response is held out by the white blood cells or the lymphocytes and has two types of reactions handled by the B cells and T cells. Under this are the secondary lymphoid organs, which include the lymph nodes, spleen, tonsil, and the mucous membrane. Asthma and other respiratory diseases are often linked to immune system. Asthma is caused by an overactive immune system. Having an allergic reaction is the most common example of an overactive immune system. However, there are also autoimmune diseases that does not go away with treatment. Examples of such are diabetes and arthritis. Autoimmune diseases happens when the body's natural defense system can't tell the difference between your own cells and foreign cells, causing the body to mistakenly attack normal cells.